We're going to now look at an example for our hypothesis testing. So let's read this. Rosie is an aging sheepdog who gets regular checkups from her owner, the local vet. Let X be a random variable that represents Rosie's resting heart rate in beats per minute. From past experience, the vet knows that X has a normal distribution with a standard deviation of 12. The vet checked the Merck veterinary manual and found that for dogs of this breed, the mean U is 115 beats per minute. Okay, so let's see. And over the past 6 weeks, Rosie's heart rate in beats per minute is measured as 93, 109, 110, 89, 112, and 117 beats per minute. So this is a sample of 6 values, 6 measurements. The sample mean is given to us as 105. It's already calculated. We could certainly find that easily for ourselves with these 6 values. Okay, so the vet is concerned that Rosie's heart rate may be slowing. Do the data indicate that this is the case? Well, what are we given? We're given that X has normal distribution. We're given the standard deviation, but the population mean is 115, whereas it looks like the sample mean for Rosie herself is only 105. So the vet thinks maybe her heart rate is a little bit too low, is slowing down. So what are we going to do? So let's look at these 4 steps outlined here. A, we're going to establish the null and alternative hypotheses. And then B, are the observed sample data, that's our X bar, compatible with the null hypothesis? So basically, is our sample information, sample data very, very different from the population information? We're going to see what is the probability of having that difference. And then if that difference is very big or very small, we'll either decide that our null hypothesis is correct and we'll stick with it, or it's incorrect and we will reject it. Okay, so let's look at A here. So if nothing has changed, then her heart rate should be nearly average. So H naught would be that the mean is 115. However, the vet thinks her heart rate is slowing. So in that case, the alternative hypothesis would claim that her heart rate is less than 115 beats per minute. Okay. So are the observed data, this is B, are the observed data sample data compatible with the null hypothesis? So are these 6 observations of Rosie's heart rate compatible with the null hypothesis that the mean is 115? So to answer this, what do we need to know? We need to know what is the probability of actually getting a sample mean of 105. So we're going to assume that our true mean is 115. It's normally distributed, and the mean is 115 for the whole population. Rosie's sample mean was down here at 105. So it's less. We want to know what is the probability of obtaining 105 or even less than that. Okay. So the actual calculation is going to be familiar from Chapter 7. So if there's a very small probability that this happens just in a random sample, then we'll conclude that the mean being 115 is not the case, and rather that the mean is actually lower than 115. So if it's a very, very small chance to get a sample of 6 with a mean of 105, then we'll say that we're going to reject H naught and we'll go with our alternative hypothesis. If, on the other hand, there's a pretty good chance of getting a sample mean of 105. If it's not a small probability, then we'll say sounds fine. We don't have enough reason to switch and say our mean is anything else, and we will stick with that the mean is 115. So how do we compute the probability? So we want to know what's the probability of getting 105 beats per minute or even less. So we're trying to compute the probability that x bar is less than or equal to 105. This calculation is the same as what we did in section 7.5 with the central limit theorem. So nothing new in terms of the calculation itself. So we're going to use a sampling distribution and compute the probability that x bar is less than 105. So since x has a normal distribution, this is given to us. X has a normal distribution. So x bar has a normal distribution. So for any sample size, and we are given that the standard deviation of the population is 12. So we calculate z as we have before, and we end up with z is negative 2.04. In the context of these hypothesis testing, this z value is called the test statistic. So what is the probability? Well, we look up negative 2 on our z-table, or negative 2.04 on our z-table, and we end up with the probability of 0.0207. In the context of this hypothesis testing, we call that probability the p-value, just as we have a specific name called the test statistic in this context as well. But the calculations are the same. You have a sampling distribution, you convert the x bar value to a z value, you look it up on your table to come up with the actual probability. So what is this probability telling us? This says that there is a 2% chance, or 2.07%, there's a 2% chance of getting 105 or less as your sample mean when you select 6 items out of the population. So that's a pretty small chance, it seems to me. Okay, that's pretty rare. So D, what conclusions are we going to draw? Well, let's read the part in blue here. If H naught, our null hypothesis that the mean is 115, is in fact true, then the probability of getting a sample mean of 105 is only about 2%. That was our p-value. Because this probability is small, we reject our null hypothesis and instead conclude that the alternative hypothesis that the mean is actually less than 115. We don't make a claim as to what it actually is, just that it is less than 115. And so therefore, Rosie's heart rate does seem to be slowing down. So we're not proving whether the null hypothesis is true or false. We just have enough information to conclude that we are going to discredit it, that we will reject it. Because we only have a 2% chance of getting this value randomly, we think that's really small, so we're going to reject our null hypothesis. Okay, so you can pause this video, you can read this again. The third video, we're going to get into some of the terminology that we're going to be using. You've already seen that we're going to call our z-value the test statistic and the actual probability our p-value, but the calculation is very similar. So there's a little bit of terminology we'll need to look at for this section, so this would be the third video.